All right, this is lesson 9.4, solve linear systems by multiplying first. So we're still looking at systems of equations, and now we're just going to look at a few examples. All right, so what we want to do is eliminate one of our variables. So we've got x and -3. So I can multiply the whole first equation by 3. That means we'll have 3x and -3x, and I can eliminate my x's. Now, when I multiply, don't forget you have to multiply by the whole equation. So our first equation is now going to be 3x plus 3 times 4 is 12y equals, and 3 times 20 is 60. This equation I don't have to change, so I'm just going to bring it down. And now that my x's line up to eliminate, I can add my two equations together. So if I add these two equations together, x's eliminate, and I've got 12 plus 7, which gives me 19y. And then I've got 60 plus 35, which is 95. Then I'm going to divide both sides by 19. And 95 divided by 19 is 5. So y equals 5. Once I find y, then I have to take this and substitute it in either here or here. It doesn't matter which equation you choose. Plug it into one of your equations and solve. Since this one has an x by itself, I'm going to use the first equation. So x plus 4 times 5 is equal to 20. So 4 times 5 is 20. And then I'm going to subtract 20 from both sides. And that gives me x equals 0, because this cancels and this cancels. So that's my x value. So my ordered pair would be 0 and 5. All right, so to check my answers, I'm just going to plug them into my equation here. So this is my x, this is my y, so I'm just going to substitute those in. So for the first equation, I'm going to have 0 plus 4 times 5, and that should equal 20. 20 equals 20, so this one works for the first equation. And then I'm going to plug it in and check the second equation, -3 times x plus 7 times y. Does that equal 35? All right, 0 times anything is 0. So this is 35, and that equals 35. So it works for this equation as well. You can see that checking these are very quick and easy. There's absolutely no reason why you should miss these, because you can check them and make sure that you got the correct answer. All right, let's look at another example here. All right, this time we have 2x and 6x and 3y and 4y. So we can look at the x's and see that both of these are multiples of 6. This one's already a 6, but I could easily make this one a -6 by multiplying by -3. So I'm not even going to look at my y's. I can see that those are both multiples of 12, but I would have to multiply both equations, where if I look at this one, I only have to multiply the first one. So let's multiply the top by -3. And so my first equation, my new equation, is going to be -6x minus 9y is equal to -36. Now, my x's here, I don't have to change, so I'm going to leave my second equation for now exactly the same. And again, I set mine up to add because I would prefer to add than subtract. So I add these two equations together. My x's eliminate. -9 plus 4, -5y equals -36 plus 26 is -10. Divided by -5. Y equals 10 divided by 5 is 2, and a negative divided by a negative is a positive. So this should be y equals 2. And then we're going to take that, and again, we're going to plug it in for y here or here. Doesn't matter which equation you choose. That's what we do to have only one variable. So let's just use the first equation. So we've got 2x plus 3 times y, y is 2, and that equals 12. So we've got 2x plus 6 equals 12. Subtract on both sides. 2x equals 6 divided by 2. X equals 3. Alright, so our ordered pair is 3, 2. And let's check these. Alright, so we're going to have 2 times 3 plus 3y. And our y is 2 in this case. Does that equal 12? Alright, so we've got 6 plus 6 equals 12. That is true. So we can say this equation works. Now we'll check the second one. So 6 times x is 3 plus 4y. Y is 2. And this one equals 26. Alright, 6 times 3 is 18 plus 8. And does that equal 26? 18 and 8 is 26. 26 equals 26. And again, we can see that very quickly. We can check those and know that we have the correct solution. Again, if you want to put it in slope-intercept form and graph it, you could graph it and find the intersection point and also see if the intersection point is the same. That's another way to check it. All right, let's do one more example. This one has -5 and 2 and 5 and 2. So both of these are multiples of 10. Doesn't matter which one you want to use. You're going to have to multiply both equations. So let's multiply the top one by 2 and the bottom one by 5. So again, remember you got to multiply the whole equation by those. And then we will have our new equations. So we're going to have -10x. 2 times 5 is 10y. 2 times 20 is 40. 5 times 2 is 10x. 5 times 2 is 10y. And 5 times 8 is 40. All right, so what we're going to do is add our equations together. So we're going to get this eliminates. We're going to get 10 plus 10, 20, y. 40 and 40 equal 80. Divide both sides by 20. 80 divided by 20 is 4. All right, so take y, substitute it back in. You don't have to solve for x each time. It just happens to be that's what it has done, but you can eliminate either variable and solve for the other one first. It doesn't matter. All right, so let's, this one has smaller numbers, so let's pick the second equation. 2x plus 2 times y equals 8. So 2x plus 8 equals 8. So I'm going to subtract 8 from both sides. 2x equals 0. Divide by 2. 0 divided by anything is 0. So my x is 0. My y is 4. And don't forget to check it. So we're going to say -5 times x. X is 0. Plus 5 times y is 4. And we want to know if that equals 20. This cancels. 5 times 4 is 20. 20 equals 20. All right. So the next one is 2 times 0 plus 2 times y. And does that equal 8? So this one cancels again. 2 times 4 is 8. 8 equals 8. So this one works as well. So you can see that your ordered pair, 0, 4, does work for this system of equations. And that's your solution. You can also use substitution or graphing to check those as well. If you have any questions, please let me know.